What is electron? Electron is a stable subatomic particle with a charge of negative electricity. Ahem, the electrons move around the nucleus. Each element has its own electronic configuration. What is orbital? An orbital is a three-dimensional region dot in space around the nucleus where there is a high probability of finding an electron. For example, there are high probability of finding a human in the Earth. So, we assume that the human is the electrons and the Earth is an orbital. Hope you guys clear about it. What about an atomic orbital? An atomic orbital describes the energy level or shell. Then it describes the distribution of electron density in a region. The higher the electron density, the higher the probability that an electron may be found in that region of an atom. It can be pictured as electron cloud. Each of the electrons in an atom is described and characterized by a set of 4 quantum number, namely as principal quantum number, angular momentum quantum number, magnetic quantum number, and spin quantum number. What is principal quantum number, or we can symbol it as n? N is equal to positive integers start with 1, 2, 3 and more. Principal quantum number indicate the energy level of an orbital in that particular orbital. Relative size of orbital and relative distance of electron from nucleus. For an atom, when the principal quantum number increase, then the energy level increase. So here is an example of its orbital. When the number of n increase, so the size increase too, as well as energy level. Wait, but what is the s orbitals? Okay, so let me tell to you about angular momentum quantum number, or it's symboled with Latin letter L in lower. Angular momentum quantum number related to orbital shape. L indicates shape of orbital. The orbital shape depends on numerical value of L. If L equal to 0, then the symbol is S. The orbital shape of S is spherical. Then, when L equal to 1, then the symbol is P. The P orbital is in dumbbell shape. When L equal to 2, then it's symboled as D. The D orbital shape is cloverleaf. Last but not least, when L equal to 3, then it's symboled as F. The F orbital shape is double dumbbell. Here is the examples of the orbital shape of S, P, and D. Next is about magnetic quantum number, or its symbol is M. M indicate orientation of orbital in the space around the nucleus. M is equal to the integer from negative L to positive L. L determines M. Number of possible M values is equal to 2L plus 1. For example, if L equal to 1, then we can find the possible M values with 2 times 1 plus 1. So we know that the possible M values are 3. What is electron spin quantum number, which symboled as S? S is determined the direction of spinning motions of an electron, which is spinning on its own axis. The electron spin quantum number has a value of 2 possible motions of an electron, which is clockwise or anti-clockwise. Now we want to explain to you guys about the shape of p orbital. P orbital has 2 regions or lobes is in dumbbell shape. There are 3 p orbitals, which is px, py, and pz. It has a specific orientation in space. It is because of when L equal to 1, then the value of m is 3, which is -1, 0, and +1. Next is the shape of d orbital. When L equal to 2, then m values are 5. It is -2, -1, 0, +1, and +2. The exact power of 2 has 2 major lobes lie along that axis, and donut-shaped region at the center. The other 4 orbitals are cloverleaf shaped. Do you guys know how to write a quantum number set? Each electron in an atom is described completely by a set of 4 quantum number, which is n, l, m, and s. N, l, and m describe its orbital, while s describe its spin. We give you an example. So each atom has 1 electron in orbital 1s. So its quantum number set is n equal to 1, l equal to 0, m equal to 0, and s equal to +½ or -½ These is the points to remember. Atomic orbital with the same value of n and l are said to be degenerated. Therefore, there are 2 l plus 1 degenerate orbitals for each value of l. The maximum number of electrons in a particular energy level, n, is given by the expression maximum number of electrons equal to 2 in power of 2. After you guys have a knowledge about set of 4 quantum number, which is n, l, m, and s. Now, let me introduce to you guys about electronic configuration. Electronic configuration describes how electrons are distributed among the various orbitals in the principal shells, or main shells, and subshells of the atom or ion. The distribution of electrons are through orbital diagram and SPDF notation. In order to write electronic configuration of an atom, 3 rules are used. The rules are off-bow principle, Pauli exclusion principle, and Hund's rule. Off-bow principle state that electrons fill the lowest energy orbitals first and other orbitals in order of ascending energy. Then, Pauli exclusion principle says no to electron in an atom can have the same 4 quantum numbers n, l, m, and s. Hund's rule states that when electrons are added to the orbitals of equivalent energy or degenerate orbitals, each orbital are filled singly with electron of the parallel spins first before it is paired. Electronic configuration of an atom's main group atoms may lose or gain enough electrons so as to form stable noble gas configuration. Electronic configuration of ions, monatomic ions, which is cation. The electrons are removed from the orbital of the highest energy